So the first step says to calculate the volume of 6 molar sodium hydroxide required to prepare 500 mils of 0.1 molar NaOH. So we're going to use the dilution equation. Final concentration times the final volume is equal to the initial concentration times the initial volume. We have the initial concentration is 6 molar. We don't know how much we're going to use yet. That's what we've got to figure out. And then we want a final concentration of 0.1 and a final volume of 500 mils. So we'll put everything in. This marker is working horribly. They're sitting at my desk for months and months, but I think we can see it. Okay, and just to cut to the chase, when we do it really quickly here, and it's really just this. So really what we want is approximately 8 mils that we're going to add in of the 6 molar sodium hydroxide. We don't have to be any more precise than that, and we'll see why in the next few steps. All right, so we have our 500 ml bottle, we have our 8.3 mils of sodium hydroxide, and then 300 mils of water here, distilled water, and then some more over here to finish up, because that's what we're going to be adding in the water and the sodium hydroxide until we're to about the shoulder. And that doesn't seem very precise, and it's not. It doesn't have to be. We're going to, once we make our solution, as long as with what we do here, it's going to be approximately 0.1 molar. And the reason we don't try to be exact about it is that sodium hydroxide is hygroscopic. In its solid form, it absorbs water from the air. So as you're trying to make up the solution with the sodium hydroxide pellets, they are changing mass on the balance. So you're really not sure what you got in there. We know that it's going to be close to 0.1, but we're going to find out exactly using a titration with KHP. We'll talk about that next. But first, let's make the solution here. So it says first to add in 300 mils of water. When I'm doing this in the class, I just tell my students add it up to about halfway. Well, the reason we're doing this is so that the mixing of the sodium hydroxide will be easier. You just put in the sodium hydroxide in the bottom and then add in water. It's not as certain that we're getting a full, complete mix. So put that in there, and then we put in the sodium hydroxide, the 8.3 mils. And then we're going to add more water here. So that's already kind of mixed. We add this in, then we're going to mix it up some more. And we're just going to add to about the shoulder of the bottle. And that's going to be around 500 mils. And that's close enough because we're going to figure out the exact concentration later. Cap it off and then just shake it. You have to, not like a bartender shaking up a drink here. You just need to. That should about do it. And that should be perfect. And this is going to be what we're going to use for all the titrations that we do in this lab. We're going to do 12 of them. So this is our approximately 0.1 molar sodium hydroxide, and I'm going to label that later. Here's the calculation for the sulfuric acid. It looks almost the same as for the sodium hydroxide, but we need 0.15 molar sulfuric acid and 100 mils. So, and then it's still 6 molar for the stock solution of the sulfuric acid. We put that into the calculation and we end up with 2.5 mils of sulfuric acid that we're going to dilute. Right, so we need to take this 2.5 mils of the sulfuric acid and dilute it to 100 mils. Now the book has one way of doing it. I'm going to do it this way, where I'm going to put in the 2.5 mils of the sulfuric acid in here, and then I'm going to fill it up to the 100 mil mark. That's a quicker way, and I think it's even more accurate than what the book suggests. So we're going to do this. That's the 2.5 mils of the sulfuric acid. I'll tilt it up a little bit here. There, okay. And then fill it up the rest of the way with distilled water. And for this one, again, we're going to get 0.15 molar sulfuric acid, but it doesn't have to be incredibly precise because this is for our practice runs. We want it to be very close to 0.15, but we're not going to sweat it if we're slightly off. Okay, but it's just to get us used to titrating. And then the KHP titrations, and then the unknown titrations we're going to do very, very carefully. Okay, stir this up a bit. And it's nice and ready to go. It's labeled, and we're all set. So I'm going to prepare this sample for the sulfuric acid all at once. Normally you do all three. You know, you put in the sulfuric acid into 1, 2, 3, and then add the water, and then the phenolphthalein, or phenolphthalein, either way. This is the indicator. This is what's going to allow a color change to be seen and for you to know that the titration has ended. So let's do this. I have the 10 ml volumetric pipette and the pipette filler, and this is our sulfuric acid solution that should be about 0.15 molar. I'm going to draw up 10 mils, and the line is above the bulb, if you remember from experiment 1. And because I'm so old, oh, there it is. Okay, I see it. It's very faint. And this one, it's not even painted on; it's etched in. And there we go. I see it. Okay. And then I'm going to just transfer here. Hit the trigger. That will release the sulfuric acid. And that's 10 mils of it. And I'm going to do this 2 more times. I'm not going to show you them, I'll show you the end result of them. But this is good for, see how it works, and then put in the 50 mils of distilled water. This is mainly so that you can have an easier time seeing the color change. You don't actually need it as far as the reaction, but when you see the whole thing change color, it's a lot easier than just a little layer of it. And then it says put in 5 drops of the indicator, and if you put in 6 drops or 3 drops, it doesn't really matter. Mix it up there like so, and this is our first sample. I'm going to do this 2 more times. Here are the 3 samples for the sulfuric acid. Each one contains 10 mils of the 0.15 molar sulfuric acid, 50 mils of water, and then 5 drops of the indicator. So these are ready for titration. Here is the entire titration setup. At the top you can see the burette funnel, the little plastic funnel for filling the burette. The burette is the long glass column. At the bottom is the Erlenmeyer flask. It's empty right now, and in the burette right now is distilled water. So I'm going to show some things that you can do for the technique. And in that burette, or in that beaker on the left, is distilled water right now, but that's going to have the sodium hydroxide in it. You always want to use a small piece of glassware to fill the burette. You don't want to use that big bottle. That's too dangerous. All right, let's look at some things here. To fill this, hold this funnel, pour in the solution, and you want to fill it right to the 0, but if you go past it like this, it's okay. This out, that way. And I'll show how you use the valve here at the bottom, but you can see that the 0 is here and the water level is here, but you'll just open up the valve slowly and let the water run into a waste container, and the level should go right to 0. So you don't want to use a pipette to try to draw the solution back out. You can just run it through into a waste beaker. All right, again, this is just distilled water in the burette. Just want to show you the valve here. When it's crossed like this, it means it's closed. When you turn it like this, it's opened. I think you can see the water going in. And you can control, whoops, yeah, it's hard. You can control how much water comes through by turning this. And each burette's going to be slightly different, but it doesn't take long for you to get used to how fast the solution is coming in. You can slow it down all you want. Just right. Or you can have it just fly through. So when you do this out, you get each burette, you get the hang of it pretty quickly. All right, here's the burette with the solution flowing. Each of those numbers means a mil. You can see that we're coming up on adding 40 mils right there. And then each of the little markings, that's a tenth of a mil. So that's 40.1, 40.2, 40.3. And you can see, you can also estimate in between those lines. So if when you're done with the titration, if it's in between those lines, you'd add in the hundredths place as well. So we'll do that when we do the actual titration, but that's what it looks like. I use the funnel and the small beaker to fill the burette with sodium hydroxide solution. That's the only thing that will ever go in the burette for the experiment. Here's the sulfuric acid run 1 ready to go, and then here's the burette filled up to the 0 mark, and we're all set to go. So this is the first run for the sulfuric acid titration. You may notice the label looks a little bit different, and if my shirt shows up, you'll see it's a different color shirt. This is a different day. I just realized when I was about to start that I did not have enough time to finish all the titrations. So I'm back. Same solutions, just had to remake this sample. So this is the 10 mils of sulfuric acid, 50 mils of water, and then 5 drops of the indicator. So I'm going to run through this whole thing. Just from this perspective, I won't show the solution draining down through the burette. I already showed that, and that's what it will basically look like. It's going to end up being some number, and then I'll show you that one. And I'm going to do this one on camera, this run, and then the other 2 runs I'm just going to give you the data. I'm going to do that for each. So you're going to have 4 titrations that are shown for each of the different samples, and then I'll give you the rest of the data. That will save a little time for the video. And so let's try this out. So this is the first one. So when you're doing this out, I'll make sure I'm at 0. So you start it out. First thing you should see when you start is that pink color. So that indicates that you have the indicator. If you didn't, by now, if it looked like that, nothing had happened, that's probably what you did wrong. So you didn't put the indicator in. Now I'm going to, hold on just a second. I got the burette a little high. There we go. Don't want it spilling out. Okay. And so what I'm going to do is just run this pretty fast for now. And I'm just going to swirl. And you can see that I stop. That the pink color indicates basic solution. That's what's gone in, is the sodium hydroxide. And then when the sulfuric acid catches up, it neutralizes the base, it goes back to colorless. So when the color stays, that means all of the sulfuric acid is gone. We know the titration is done. And you can see now that color is really coming. I'm going to slow it down now. Okay. Oops. Yeah. You can see it shows up, dissipates, shows up. I'll swirl it. I can make it dissipate by swirling. So, where are we here? Okay. Swirl, swirl. And so we must be getting near the end. I'll just put in a lot of different ways you can approach this. You can just do it drop by drop, or you can just put in some, and then, so the fact that the color stayed around for so long shows that we're nearly there. What we'd like is the lightest color pink that's possible. And from my perspective, I don't know if you can see it. Yeah, there's just a slight hint there. We're right at the end of it here. So we're almost to the end point. So I'm just going to put in a drop, see how that looks. So that was 1 drop, and the color is there, and it's fading. So I'm going to just look at it for a second here. It is just below 32. Yeah, that makes sense. Okay, and then put in one more drop. And yeah, this time the color has stayed. It's very, very faint. That's what we want. So we're right at the end point. That looks good. So let me, I'll show you the volume here. All right, here's the volume that was added. And I'm thinking it's past 32, it's past 32.2. And I would say that it's something like 32. It's a little bit lower than the 32.2 mark, so I would estimate it at 32.21. That will be the volume for run 1, and then I'll just show you the volumes for the next 2 runs that I did rather than show those 2 titrations. So for the next 3 samples, we need the KHP, which is potassium hydrogen phthalate. It is an acid, but it's a solid one. And we keep it inside this desiccator to keep the water out of it, because we want it to be completely dry. So whatever mass of potassium hydrogen phthalate we see on the balance is all due to just the KHP, not to any water that it's absorbed. So we take off the top here. All kinds of desiccators. This is a pretty small one. Here is a sample of KHP. And then inside here you see the dryerite, those pellets. That's anhydrous calcium sulfate. Anhydrous means there's no water in it. This actually has quite a bit. It looks like it's older. But it's to keep the water out of there, so we don't need this guy. We just have this. Now this is going to be a little tricky to do without blocking the camera. So I do something a little different than the lab book says. I'm going to use 0.4 grams. I found that works really well. So I'm going to just put the 0.4 grams in. Again, tricky here because I can't get around the camera very well, but what I'm going to do, use our scupula here and just put in enough, can I read that? Yeah. To get around 0.4. It doesn't have to be exactly 0.4. Sometimes I forget to tell students that, and see they're at the balance for about 10 minutes trying to get it exactly 0.4. The reason I use 0.4 is because you get a good volume of sodium hydroxide that's used, but not too much. So you don't want you want to have somewhere in the teens or low 20s. That's what we're hoping for here. If you use 0.6 or 0.8, you might end up having to refill your burette. Okay. So actually any amount will do, but it's just a matter of how much sodium hydroxide you want to use. Well, closing in. See, secretly hoping to get exactly 0.4, but again, I can't spend the entire day on it. Okay, we'll try one more. Ah, that'll do. So 0.397. So it doesn't have to be exactly 0.4, but whatever it says on here, you want to make sure that that is what is shown. So I'm going to do out the one sample, so and then I'll show the data for the others. So what I'll do now is take this solid acid, and it's going to go into the flask here. And then I'll do that with 2 others, but I'm just going to show this one. All right, so I moved the KHP into a larger flask here. I forgot that we need for this one, we need 75 mils of distilled water. We need so much water because we need to dissolve the KHP. And it takes a little bit of effort to do that. Let's swirl this around. If you don't get all the KHP in, as you titrate, as you swirl, it will go in, but there's a chance that some of it will remain behind. So when you reach the end point, it's nice, and you have the color change, then it'll just disappear because it's still working on the KHP that's dissolving. So it can be kind of frustrating. So we want all of this to go in. I'm just going to put in the indicator. And then I'm going to continue to swirl this around. Let me see if you can. You can see, yeah, you can see there's stuff on the bottom. So this will take a couple of minutes here. I'm just going to swirl around, make sure it's all in before I start the titration. All right, I think I said 18, but now that I have my glasses off, I can see it's 19.72, I guess. 18, that last one is a guess. It's estimate. 19.567. Yep. So 19.72. So I've begun this titration of the KHP, and right now I'm at about 11 mils, so I'm just going to keep going so you don't have to watch the entire start to finish here. You know how it's going to play out now, but let's just see the end result. Okay, you can see just adding a tiny bit of the sodium hydroxide, and the color stays for a long time. Don't want to overdo it here. If you do, a lot of times it looks really bad. It's almost fluorescent, but really you've only overshot it by maybe even a few drops. That's all it would take. But we want to get this one really as close to the true endpoint as possible. Since this is the one where this is the titration that we're going to use to standardize the sodium hydroxide. The sulfuric acid was just for practice, just to see how things went. And you do a calculation on it, but this is the really important one because the KHP it was dry, so we know exactly what its mass is. We know what its molar mass is, so we also know the number of moles. And it's a one-to-one reaction, so if we know the number of moles of KHP in the reaction vessel, we know the moles of NaOH. And if we divide that by the volume of NaOH, we know the exact concentration of the NaOH. We go, I overshot it just slightly. Opening and closing it like I did there, that's probably less than 1/4 of a mil. So even though it does look a lot brighter than the one that I did earlier, it's probably not too bad. So we'll just, but now that I know where it is, and I'll show you, but it looks like about 18.7, something like that. Now I know exactly where I should be going for the other two titrations I'm going to do, so I shouldn't overshoot those. And here's the preparation of the HCl unknown that's here. So we don't know what's in it. That's what we're going to determine now that we know the concentration of our sodium hydroxide. Use this 10 ml pipette. Dial up 10 mils of HCl. Just fight me a little bit. That's good. And then we're going to take this over here, and in we go. So that's 10 mils of the HCl. And then we're going to add in 50 mils of water. So it's over here. 50 mils of distilled water. Normally I wouldn't have all this stuff clustered together. I just want to make sure everyone can see it in the same frame here. So we have the HCl, the water, and then 5 drops, 1, 2, 3, 4, 5, of our indicator. And that's I made the first sample, and I'll do the other 2 the same way. And then we'll titrate. We join this titration in progress, and you'll be glad that you did because we're already to 30 mils, and it's taking a while. This is the unknown HCl. I have no idea what it is. It could be, it's not going to be like 10 molar or anything, but it can be pretty high. So, closing in. All right, so this one now let's be careful. And I didn't say it in the earlier video, but it shows it there, but this is unknown 16. Ooh. Color stayed. Oh, can't quite see it. There we go. And that was really just a couple of drops and it made all that difference. Okay, so that is the end of the titration. And here's the final volume for the HCl unknown. Looks like, oh, like 33.49. Here's the first run of the acetic acid unknown, and I've just left the bottle here. It's unknown 5, but I've already been working on this. I didn't show the preparation because it's the same. You can see this is a liquid, so I just took 10 mils of this, 50 mils of water, and then 5 drops of indicator, just like I did for the HCl. So let's see where we are here. Yeah, you can see already. We're at 14 mils, and it's coming up on the end. This is just so you can see that each of these different acids does the same thing. And the acetic acid, for the report sheet, you'll be asked to do some further calculations with it. Whoops. Did I? Nope, you can see we're very close there. Even when it's all gone, there's this, I mean, I don't know if I can see it. Yeah, there's a slight sheen there. So what I'm going to do here, what you want to do when you're that close, you just flip it once. You just do this really fast. Flip. It looks cool, or as cool as we get in chemistry. And that puts in about a drop, and that's all we needed. Okay, so let's see what the volume was. All right, so I'm thinking it's 17.48 for the volume for the first acetic acid unknown titration.